Hello, everybody. Good morning and good afternoon. And very happy to take part in UITP online course. And I'm sorry my English is not good, so I will speak in my mother tongue, and my translator will help me for your English. 这个非常高兴来参加 UITP.
I'm very glad to attend this seminar. And today I'm going to talk about international market overview of electric buses and charging infrastructure. I've been in this industry for 40 years, and I would like to first talk about my career with you. I am actually from a university, a Chinese university, and my specialty is about transportation and vehicles. Back in the 1990s, when highways in China were in full swing, and at that time, I paid a lot of attention to road vehicles. In recent years, under government support, electric buses have enjoyed rapid growth, so I have been closely followed this area. And of course, I have been very active in UITP and other industry organizations to have as much communication as possible with peers all over the world. In this process, we have introduced a lot of products and technologies into China and transferred Chinese technologies and products to other countries. We have also worked with AIIB and other multilateral banks, such as Asia Development Bank, to promote those projects. And of course, in my career, I visited many cities and countries. And I do notice from different areas, they have adopted different technological routes. And I have also involved in the R&D of some specific products. That is why I would like to share with you the international market overview of electric buses and charging infrastructure. I will first talk about policy context and city strategies for the introduction of electric buses. Next, I will compare the charging infrastructure for electric buses as opposed to diesel buses. It requires a brand new systematic approach for us to install those infrastructure, and that will decide on our procurement plans. For operators, they need to purchase not only buses, but also charging devices. That's for operators. And for governments, they have a broad picture to think about. In China, Europe, and other regions in the world, we have some different concepts when it comes to electric buses. In Europe, they call it clean bus and zero emission bus. But in China, we call it new energy bus. Actually, there are some nuances among the three concepts. Let me start with electric buses. An electric bus is a bus that is propelled using electric motors. That's electric buses in its general sense. But we can also talk about hybrid electricity that's plug-in buses. But in the narrow sense, as long only buses which are driven by batteries are electric buses. It's all about batteries instead of generators. And when we talk about electric buses in the narrow bus, sometimes we don't include trolleys. In the broad sense, trolleys and plug-in buses are also electric buses, but in its narrow sense, only battery buses are electric buses. In China, when we talk about electric buses, the policy are all for battery buses. But now we're also talking about hydrogen fuel buses, FCVs, because hydrogen buses, hydrogen FCVs are also clean. So sometimes the policies can also cover hydrogen buses. So why we should electrify our buses? That is because we would like to cut as much emissions from buses and vehicles as possible. In the last century, it was found that smogs were usually caused by emissions from vehicles. So at that time, it started first in the US. The US government was the first one to draft emission standards, and then the EU and China. Now almost all governments in the world recognize the need for clean standards for vehicles. Now we have the Paris Climate Agreement because people have come to a consensus that we have to do something to mitigate climate change, to save the planet we call home. That's how the Paris Climate Agreement came into being. Almost all countries in the world promised that we will try our best to limit the temperature increase within 1.5 degrees Celsius. Every country and every individual is obligated to contribute to that goal. Many countries have required this through legislation. For example, in Europe, in 2021 to 2025, it's required that 45% of buses required should be clean buses. And also in the second stage, from 2026 to 2030, the ratio should go to 65%, and half of them are zero emissions buses. Because of those kind of legislature, public operators have to electrify their bus fleets. Over the past 100 years, people first favored diesel buses because it's cheap and accessible. And later, people realized we should cut down the emissions of diesel vehicles. And the ultimate goal should be zero emissions. But of course, in this process, we have to think about replacement fuels such as LPG, CNG, and hybrid power such as small generators. All of them are part of the solution. But of course, battery, hydrogen are more promising. but it will all depend on how mature the technology can become in the near future. So when we talk about electrification, it's not only a challenge for the transportation industry, it will also pose a question about the source of electricity for the power sector. If electricity comes from coal-powered plants, then it's still gray electricity. But if the electricity is from solar, tidal, geothermal, then it's totally clean electricity. So that is about the industrial chain from the upstream to the downstream of electric buses. Of course, this is quite a severe challenge, not only for transportation, but also for the power industry and for the energy sector. Traditionally, vehicles are driven by ICEs, and through the powertrain, the wheels could be running on the road. But after electrification, there will be no ICEs. Instead, batteries are what to drive the wheels, and the powertrain remains between wheels. And you can compare the two structures. They are totally different. But if we don't put the powertrain on the axles, we could also put the powertrain on the wheels, on the hubs. People used to predict what electric vehicles would be look like long ago, actually back in the 1950s, in some sci-fi magazines. That's how an electric vehicle would look like. And as you can see, the motors are in the wheels and the batteries are between axles. The body is quite lightweight.
So in this way, the whole structure differs a lot from the traditional diesel vehicle. Yes, that's a huge difference. So in this scenario, we gotta be very careful about technologies. Let's look at this roadmap. In the first place, we had diesel, and then we could combine electricity and diesel. That means we have kind of a diesel generator to get electricity, which drives the bus. So in this technology, the power from the diesel generator could be quite stable, but the efficiency is quite low. In ideal working conditions, we have to do a lot of calculations so that electricity can be stored when the vehicle is not moving. So when it's finally moving, the stored electricity can be put into use. That's the rationale behind the combination of diesel and electricity. So going further, we could replace the diesel generator. So let's talk about the case of the tram. The tram can get power from the current grid. During the process of moving the vehicle, there could be certain cases where the pantograph is removed from the grid. That's going to cause a lot of interruption. So maybe we can put a battery on board so the tram can get electricity through the pantograph during normal operation. And when there is any disruption to the power supply from the grid, the battery could drive the vehicle. And also sometimes we can have a more advanced charging network. There is an overhead network above the vehicle. You can see this roadmap. So that's how we can get to the point of developing battery electric buses. So when we have electricity, we got to consider how electricity gets to the wheels, how we can drive the bus forward. After replacing ICE with electricity, we got to think about the whole architecture. So from electricity, we can go to a power inverter, and then there is a central motor, the gearbox, and finally a differential gear for the wheels. But we can also have a better architecture. As you can see in the right part of this page, electricity can go directly, or at least go to the wheels in a more directly manner. So how we can drive the vehicle with electricity, that's a fundamental issue. And in developing electric buses, we must think about how that can happen efficiently and effectively. So here, let's compare a few models. So in the past, we had the so-called central E-motor. This E-motor replaced the engine, and then we could have the wheel hub E-motor. And we could also put the E-motor inside the wheel. That's going to be even more efficient. So those are three different pathways forward. All of them can be commercial. But in our practice, we got to make a choice. The wheel hub driving mode has become mainstream. The central E-motor has been on the decline. As for the in-wheel E-motor, it's also gaining popularity. As a new technology, there has to be a gradual process of maturing. When we have the powertrain in place for electricity, we got to consider how we can get electricity. The voltage has to be high. And this kind of power source differs a lot from civil use electricity. We must have a high voltage. And the electrical power is related to the charging speed. So the capacity and the size of substations must be configured properly. All those factors could have a huge impact on the operation of electric buses. We can build charging stations for electric buses. The charging stations are kind of a connecting point between the grid and the vehicles. When a vehicle arrives, there could be some kind of connector transferring electricity from the grid to the vehicle. So this set of infrastructure really matters. Without all this, the electric vehicle cannot run effectively. I mean, it cannot get enough energy to run. That's very simple, a simple principle. It's just like building gas stations for gas or diesel vehicles. In practice, there has to be a lot of factors to consider. We can choose manual operations for charging. There can also be mechanical and automatic charging methods. In China, we have a lot of workers working at the charging stations to connect the vehicle to the charging infrastructure. But in certain developed countries, they have better facilities. As I mentioned, there could be a pantograph connecting the bus to the infrastructure. This can reduce manual operation. On one hand, that's more efficient. On the other hand, safety can be improved. However, If you use a pantograph for this connection, there has to be additional facilities in place. It's not about simply connecting a connector between the vehicle and the grid or the infrastructure. As for how many batteries to configure for a single vehicle, that is quite technical and depends on actual situations. As for charging speed, there could be fast charging. There could also be slow charging, depending on the features of the battery. And we gotta have a proper balance between the capabilities of the battery and the charging speed. That also means we gotta have a systematic approach in terms of technologies. We gotta consider all the technical features of the electric bus. For example, we got to look at the overall situation of technologies. We got to consider the body type, the drivetrain, the battery cell properties, the charging infrastructure, and also auxiliary devices. So that is from the perspective of the vehicle. Plus, the vehicle operates in a certain setting. In that setting, there is different parameters, including the road situation and the climate. The battery properties must account for weather. In very cold areas, the battery life could be shorter than in warmer areas. So we must consider where the vehicle is going to operate. Apart from that, the actual daily operation matters. You got to consider the length of a route, maybe 10 kilometers, 20 kilometers, 30 kilometers. So those parameters must be combined with the operating schedule of the vehicle. Maybe a vehicle is going to run 200 or 300 shifts or runs on the route. So based on all that considerations, we can draw a comparison between the traditional diesel bus and the electric bus. If I buy an electric bus, how much additional value can I gain from the electric bus? I need to consider which is more cost-effective, the diesel bus or the electric bus. If there is any loss from my shift to the electric bus, who can subsidize me or compensate me for the additional cost? So that's a whole picture. We got to consider all those factors and parameters. Yes, technologies matter. How do we understand technologies? There must be evaluation. Just now I talked about routes. We also got to consider electricity tariffs. In many cities, there is peak time slots and valley time slots. In peak time slots, electricity could be much more expensive than in valley time slots. Tariffs really differ a lot. We should leverage this gap between peak tariffs and valley tariffs. That's going to be a huge beneficial factor for the cost structure. And for the vehicle, there is a certain lifetime. So during the lifetime, for example, 8 years, 12 years, or even 20 years, how much value can we gain? In different countries and territories, that could differ a lot. In Europe, a lifetime of a vehicle could be 12 years. And in China, we often talk about 8 years. So in those 8 years, what's the whole cost structure like for running an electric fleet? For a standard 12-meter electric bus, how many batteries do we need to carry? Or how much capacity must be on board? If we carry too many batteries, that means the passenger carrying capacity decreases. For a whole vehicle, the weight-bearing capacity is kind of fixed or regulated by authorities. If we have more batteries on board, that could make inroads into the passenger carrying capacity. We must ensure we can minimize the number of batteries and maximize the number of passengers on board. So that's about the passenger density in different areas and in different parts of the same city. There could be some differences. In Europe, that could be, the maximum density could be about 4 passengers per square meter. And in China, that's like 5 to 7 passengers per square meter. So for the same 12-meter electric bus, some companies talk about carrying 70 passengers and some talk about carrying 80 passengers. That's because their standard for passenger density differs. So let's look at this page showing the different body types. There could be small vehicles, there could be medium-sized vehicles, there could be long vehicles. The larger the vehicle, the more power it requires. So if we go electricity, the number of batteries, the capacity of batteries must be adequate. The principle of calculating all this is quite simple. We consider the bus size, and we consider the maximum payload, so on and so forth. Of course, the maximum number of passengers differs from bus to bus. And the average battery size for electric buses could differ between China and Europe. In China, a single such bus runs about 150 kilometers per day. And in Europe, that's like 200 or even 250 kilometers per day.
So usually, according to laboratory statistics, people can decide what capacity of batteries can run how many kilometers. Without load, maybe the battery can run 350 kilometers, and with load, that can be 200 kilometers. However, that's just a theoretical data. When the buses are actually running in the cities, it will be accelerate, deaccelerate, stop, start. So it will not run at an even speed. That's totally different from the experiments done in laboratories. Especially in downtowns and in suburbs and exurbs, the road conditions are totally different. UITP has developed its sort standard to accurately reflect how many kilometers electric buses can run in different road conditions. I believe these sort standards can offer very good guidance for the procurement and planning of electric buses. Here are some data and pie charts for the actual road conditions in easy, urban, suburban, and etc. For public transportation operators, your data can be very meaningful for those operators operating in similar cities. Right now, like I mentioned, we already have a very good guidance, those sort standards. And then we will think about the strategies and the willingness of the city on e-buses. If we already have the political will for roll out electric buses, then it will start some pilot programs and then scale it up. And next, I will talk about e-bus procurement. It has been a quite standardized process. It has to be an open bidding. Many bidders will participate, and through the sort tests, we will look at the energy consumption parameters and the performances of buses from different bidders. Of course, we are sensitive to vehicle prices. In addition to prices, we will also think about power consumption and other key elements. In addition to those conventional considerations, we should also think about the prices and cost effectiveness of charging infrastructure, its upfront cost, maintenance cost, installation cost, and etc. And of course, for e-buses, you should also think about data. You need to monitor your buses and the electricity status of your buses, of your depot charging stations in a real-time fashion. The data can also be shared. So that's a totally different point from purchasing diesel buses. Those data are also critical for the maintenance of your e-buses. And of course, cost is very important. We should think about technological data, operational data, and then to decide whether that's a good bargain. Like I mentioned, you should first think about the vehicle itself, and then you should think about charging infrastructure. Thirdly, you should think about your staff and how to train your staff. Because diesel buses are different from e-buses, you need to retrain your staff, retrain your drivers, maintenance people, and charging staff. But of course, we should also think about emissions, maintenance, and etc. So like I mentioned, you should think about the acquisition cost, including the vehicles and the charging infrastructure, and you should also think about the operating cost. Chinese government subsidizes the acquisition cost, but the maintenance cost is not covered. If we only think about the cost per kilometer, yes, the acquisition cost seems to be quite higher if you buy an electricity bus. Or some people will claim it's much cheaper for you to buy an e-bus. But that's because you have included government subsidies. In both the EU and China, we have many cost data for reference. Next, I would like to break down the general cost for e-buses and to find out why governments like those in the EU and China would like to subsidize the procurement of e-buses. For any product, if it's mass-produced, the cost can go down. That's the same case for e-buses. That's for the purchase cost. And also we should think about the financing costs. These parts will bring some financial burden to operators, but if some financial institutions would like to fund the purchase of e-buses and charging infrastructure, I believe that will be a very good solution to alleviate the financial burden on operators. And next, let's think about the running cost. The maintenance cost is very low compared with that of diesel buses, especially in nowadays when oil prices are on a peak. Now, of course, we should also think about infrastructure costs. Like I mentioned, you need to invest in the charging infrastructure. If you only have a small fleet, if you build a charging station, that will be an overkill. Maybe you can share the charging infrastructure with other operators. And next, that's the emissions cost. Because you have introduced a fleet of e-buses, you have cut down the emissions. Somehow you have contributed to society, and that should be encouraged. That also explains why governments subsidize e-buses, because e-buses without emissions have greatly contributed to society. So only by putting together all parts of costs, then you could come to a reasonable cost of your e-buses. You should not only think about the purchase cost and maintenance cost. Some of the cost should be shared with society and the public. And here I have some data from the US. In the past around 10 years, you can see how the mix of e-buses have been changing. The manufacturing cost, procurement cost, and electricity costs are all changing. Of course, we're comparing the cost with that of diesel buses. Only when replacing diesel buses with e-buses make economic senses, the society would like to scale it up. It cannot always rely on government subsidies. And here, this is a table for the annual bus maintenance cost from Europe. As you can see, it has compared diesel buses, hybrid buses, trolley buses, dual source trolley buses, and battery electricities. Let's start with the power cost. Like I mentioned, oil price is very high. And the trolley bus is quite cheap compared with hybrid buses. From this sense, trolley buses can greatly contribute to electrification. However, in many cities and countries, they regard trolley buses as some kind of a backward technology. Now, I believe from the perspective of electric buses, you will see trolley buses are quite economical. But of course, trolley buses have the depreciation cost of the network for diesel buses, they don't require those kind of overhead lines. And let's also look at parts cost, tire cost, insurance cost, and etc. Diesel bus, hybrid bus, trolley bus actually don't make any difference if you put all things together, but electric buses will be a winner if you can think about all of the costs. Different countries will have different ways or say measures to calculate the cost. This is a table for the annual bus maintenance cost in China. Starting from the top, we have diesel buses, CNG buses, hybrid buses, battery electric e-buses, and dual source trolley buses. As you can see, the diesel buses, when it comes to procurement cost, is quite low. But in China, as you can see, the trolley buses are very expensive because in China, only around 10 cities have trolley buses running in their cities. So it cannot be mass produced. It's almost customization. That's why the trolley buses in China are quite expensive. Next, let's also look at the guarantee period. For diesel buses, it's only 2 years. And for e-buses, for motors, they're guaranteed for 8 years. That's much longer than the 2 years for diesel buses. And we should also think about the transmission, braking, and other components. E-buses are much cheaper. Compared with diesel buses, e-buses don't need to have fewer components. And lastly, we can also look at the tire cost, body maintenance cost, and the total maintenance cost. Thanks to government advocacy and government subsidies, China has introduced e-buses at a large scale for a long time. And thanks to this kind of economy of scale, people now find e-buses are quite a bargain.
For one thing, safety could be a tricky issue. We have seen a lot of accidents where e-buses simply get burned. And this kind of burning accidents have also occurred here in China. And that could be a drawback for promoting e-buses. So now, let me talk about the current state of the e-bus market. Here, we can see a comparison in terms of bus and coach prices in different markets. In Latin America, a 12-meter diesel vehicle could cost around $200,000 US, up to $225,000 US. For a hybrid vehicle, that's about $280,000 to $340,000 US. But if you go electric, the cost could almost double. That could be an upfront cost. If I buy an e-bus, I could use that money to buy 2 diesel buses. So that is a very practical issue. In China, we can see the costs are a little bit lower. In China, we have the largest capacity of mass production for vehicles. So a diesel bus here costs only like $70,000 US. And for hybrid vehicles, it's about 150,000 to 200,000 US dollars per vehicle. And for electric buses, it's a little bit higher, like 280,000 to 350,000 US dollars. In Europe, those numbers are much higher. So for an e-bus in Europe, the price tag is somewhere between 575,000 and 680,000 US dollars. In those regions, there is very little mass production. So China has this huge advantage of mass producing a lot of vehicles from different categories. Also here, you can see numbers from Russia. In Europe, about 50% of all the battery electric buses are from China. So that's the current situation of the market. China accounts for about 50% of all the battery electric buses running in Europe. So here we can see a lot of OEMs. So those OEMs are scattered across different cities around the globe. You can also see their models and the capacity and the number of seats of each model. So Mercedes-Benz produces E-Citaro. The capacity is 88 passengers, and the number of seats is nearly 30. The length of the vehicle is over 12 meters. The maximum range is 150 kilometers. And if you look at some other models, the maximum range could be longer. The maximum range used to be a huge constraint on promoting e-buses. So this company, Tamsa, is from Turkey. There are also e-Busco VDL. In China, we have BYD and CRRC. Those two companies produce 12-meter buses. Of course, there could be a very little variation in length. And the length of the bus could be relevant to the number of seats and the capacity of the batteries on board. Anyway, from this table, we can have a glimpse of the whole market around the globe. In China's public transport, there is over 700,000 buses. By European standards, we have about 500,000 buses that can be called clean. So those buses account for 72% of our whole fleet. If you talk about electric, we have about 380,000 e-buses, accounting for 54% of all the buses. In Shenzhen, Hangzhou, and a few other cities, the percentage of bus electrification is 100%. Also, China has some new policies for encouraging hydrogen vehicles. So hydrogen vehicles could have a promising future. But for the trolley bus, it's on the decline. The trolley bus is even not regarded as a kind of e-vehicle. And people do not think about the trolley bus as something very good for public transport here in China. And that's very sad. So here, let's look at the example of Shenzhen Bus Group. As you know, Shenzhen has already achieved 100% electrification for its city buses. Shenzhen Bus Group has very good operating metrics as you can see from this page, the central government offers a very good subsidy. So in the past, that's about 1 million yuan per vehicle in subsidies. That's a huge subsidy. In many cities, the governments were not financially adequate to purchase e-buses. With 100 million yuan per bus in subsidies, those governments could move forward and go electric. So subsidies really played a key role in promoting e-buses. We know that in China, the central government and the local governments both provide subsidies for e-buses. So under this dual subsidy structure, operators could really have much potential of going electric. In the past, subsidies were calculated based on the whole capacity. For example, you had 1 kilowatt hour of electric buses, or 5 kilowatt hours, or 10 kilowatt hours, you could get different amounts of subsidies. So under this incentive, a lot of operators really worked hard to develop their e-bus capacity. But that's not a healthy way forward. We gotta consider a whole balance. That means operators gotta consider the actual demand, the actual traffic, and the feasibility of electric bus projects. Now let's look at some specific models. BYD's K9 maybe has become the most popular e-bus around the globe. You could see those parameters here for this model. BYD's K9 was launched about over 10 years ago. It has been developed to become better. But anyway, that's an early model. Aptis has a very advanced model. You can see the exterior and the interior. Every aspect is just really fantastic. The passenger capacity is like 20% higher than an ordinary e-bus. It's 12 meters long, and its capacity could be equivalent to that of a 15-meter vehicle. So this company, Solaris, this company is a very active OEM in Europe. It has made a lot of e-vehicles. So this is a 12-meter e-bus made by this company. It has a large market share in Europe. If you talk about mass production, this company is no match for BYD, but its technologies and its design are remarkable. Mercedes-Benz is also a strong player. But this company actually does not think highly of e-buses. According to this company, the future of clean energy buses is all about hydrogen. So Mercedes-Benz has mass-produced some hydrogen vehicles. About 20 years ago, it talked about mass-producing hydrogen buses. But now, I don't think they have entered a real phase of mass production. Over the past 10 years, the cost of hydrogen infrastructure has declined a lot. But if you are talking about real commercialization, that is still a far way there's still a long way to go. So this company could use in-wheel motors. In-wheel motors could be very effective and efficient for e-buses. So the motor could be built into the wheel. That could improve the efficiency of using electricity. This kind of efficiency improvement means that with the same amount of electricity, we can go further. And that can also mean we can reduce the number of batteries. Plus, we could save a lot of vehicle space. So the chassis could be lower. With a lower chassis, passengers have an easier time getting on board and getting off the bus. So the in-wheel motor is gaining popularity from more and more OEMs. So here you're looking at concept e-bus from e-vehicle. The wheels are much smaller, and the number of vehicles is larger. The batteries are installed at the top. If I install a pantograph, then it could become a different form of vehicle. So with this design, the onboard space could be larger. That translates into a larger number of passengers allowed on board. During peak hours, we can have the so-called 1+1 layout for onboard seats. And during valley hours, we can change the layout to increase comfort for passengers. Look at this picture. The onboard space is really huge, and passengers could feel at home on board. Traveling by bus is no longer a very crowded experience, and that can improve the service quality of public transport. Passenger experience really benefits a lot. Of course, composite materials could be used for buses. Here, you can look at this model. Carbon fiber is used for the bus body. Carbon fiber is a very strong material.
As you can see, the buses look very sharp and neat because it is lightweight. And thanks to the modularization technology adopted by macro factories, the cost is quite low. So as you can see from design, production, and manufacturing, technologies have been getting more and more mature in the field of e-buses. Worldwide, as you can see, the adoption rate of e-buses have been greatly increased, but it still varies from country to country. In Europe, they prefer pantograph, but in China, plug-ins, OC sockets, and charging guns are more preferred in China. So as you can see, due to different environments in different countries, different models of e-buses and different technologies are adopted. Right now, in Europe, because of the legislative requirements and mandates I just talked about, now the e-bus fleets are getting bigger and bigger. Now it is to the amount of around 10,000 e-buses. Of course, the e-bus fleet in China in the past 5 years has also been on the rise. And here in this chart, in this bar chart, the green represents hybrids and e-buses. The dark green represents the diesel buses. As you can see, the diesel buses are going down and down. Electrification in Europe is more on a gradual way, while that in China enjoys explosive growth. So here I would like to come to my conclusion. I would like you to have 3 takeaways. Number 1, electric buses now can fully meet the needs of fleet management in different scenarios. Secondly, worldwide, we can see that we already have different patterns of running different e-buses. There are many existing successful examples. You don't have to reinvent the wheels in adopting e-buses. You simply have to select from those excellent OEM manufacturers. For cities, how can they make the best strategies when it comes to procuring and rolling out e-buses? Well, I think suitability is very important. What we would like to achieve is zero emissions. In this process, there are many constraints. Number 1, the economy. If the city does not have a deep pocket to get to zero emission all at once, then you can do it in a gradual way. So it all depends. Just now, I've talked about the general picture of e-buses. So here comes a question. Which one is more important, the policy context or the operational advantages? As an operator, should I be the one to make the choice to buy an e-bus, or it should be driven by the government? Well, I hope after what I've shared, you can come to your own opinion. And next, I'm more than happy to answer your questions. Moderator, would you please kick off the Q&A session?
Hi, so we have a few questions actually.
Okay.
The questions, the first question we've had is from Dick Heinrich. He's asking, when charging in depots, what is the impact of charging infrastructure on required depot space size?
Okay. 这个来讲，其实跟你的车队有关。
Well, it's a very good question. It depends on the size of your fleet. If you have 10 buses and 20 buses to get charged at the same time, then your depot should host 10 buses or 20 buses all at once. For some depots, they can also accommodate buses from other depots. In operation, we should think about the dead miles to get your e-buses charged. When drafting your charging strategies, of course, fast charging is better than overnight charging. For one route, if at the 2 depots, I can have 2 charging stations at both depots, then buses could get charged in a fast way when they stay at depots. There will be no dead miles. But that's very difficult to achieve that. That's why for many cities in Europe, they have fast charging infrastructure in bus stops. Within 2 seconds, the buses will be charged within seconds or tens of seconds. In such a way, there's no impact on the depot size. That's my answer to your question.
Okay, so the next question from Mark is, what safety requirements are recommended in depot to prevent fire accidents?
Well, I believe there are some existing guidelines and standards. For example, from the power sector, from the electricity industry, there are some requirements on insulation and the operation procedures. All of them have been standardized. When designing the charging infrastructure, there are also standards, and also there are procedures to be followed for charging. We have standardized standards to share with you. Yes, thank you.
So there's another question. The question is, if we already have AC to DC substation, would you recommend to connect the AC source directly to DC for e-bus chargers?
Well, this is quite a tricky question. Generally speaking, it's DC. But if you want to charge through AC, then it will require another system. Those standards are usually for DC when it comes to power and voltage and the charging time. When we talk about fast charging and slow charging, they actually are different technologies. And that's the same case for AC and DC. How you charge your batteries will change the performance of your batteries. I believe the next speaker will offer you more insights into this from a technological perspective. Thank you.
There are no other questions at the moment.
Okay.
If there are any other questions, you can. Here we go. Actually, Kimberlyn asked, do you recommend that the procurement of buses and chargers is done together from the same manufacturer? How is the experience of the same charger supplying
No.
buses?
Okay. OK， 这个来讲的话，这是一个技术规范跟标准的问题。
Yes, I think that is about technology specifications for OEM, the manufacturers. The OEM of buses and of chargers are different manufacturers, but they have close cooperation with each other. The data sharing and the handshaking between buses and chargers should follow some standards. For different manufacturers, they will have different levels of openness. And for chargers, they should be compatible to all buses. That's why we have talked about the synchronization or say standardization of the chargers and communications between buses and chargers. So you can buy from whatever OEM manufacturer and also buy chargers from whatever charger OEMs. That's not something you should think about because this industry already has this standard for compatibility. Thank you.
Dirk asks, I understand that in China, the operating companies own the buses. Where do you see the advantages of this model over separating operation from ownership of buses as considered in Latin America, for example?
Well, in China, the public transportation operators are usually state-owned companies. So that is to say, the upfront cost of procuring buses are funded by the government. When you talked about the Latin America case of separating operation from ownership of buses, well, I do know that. Yes, for those operators, they will operate those buses, but the buses are provided by financial institutions. So it's a way of leasing. For example, if I run those buses for 200 kilometers, I will pay per kilometer. I believe that may be a better solution for e-bus operation. Thank you.